All right, so recently I solved a problem in one of my data science projects, and I want to talk about it because I'm kind of proud that I came up with this solution. Granted, it may not necessarily be the best way to accomplish what I was trying to accomplish, but it's one way to accomplish it, and I came up with it, so I'm happy about that. So I'm going to talk about that. All right, so I have this data frame df01, and this data frame has 3 columns, as you can see, and each column has some data in it. So if I print out this data frame, you can see the result here. Now, Pandas allows you to do something called Boolean indexing, where you can specify a condition, and that condition gets evaluated into a series of Booleans. And then that series of Booleans gets used to index the data frame. So let me give you an example. So as you can see here, we have all of this data in our data frame. Let's say I wanted to get all the rows in this data frame where call O1 is equal to A. So the way that I would do that is I would specify a condition here, df O1, call O1 is equal to A. And when I run this, you can see we get the result. So what's interesting about this is that this condition, as I mentioned earlier, evaluates into a series of Booleans. So if I just use this expression by itself, you can see the result here. It's a series of Booleans. What this means is that I'm also able to pass in this series of Booleans or even a list of Booleans. And as long as it's the exact same number of rows as the data frame, or rather I should say, as long as the length of the list is equal to the number of rows in the data frame, that list is valid. So I could do something like this. I could pass in this list containing true, true, false, and false. And when I run this, it gives the same result. All right, now let's talk about the problem that I ran into. So we are able to specify multiple conditions. You're not limited to just one condition. And you can use bitwise operators, which in Pandas get used as element-wise operators. You can use bitwise operators to chain multiple conditions together. So the issue that I ran into was that I had multiple conditions, or let's call them filters, because that's exactly what I was using them as. I had multiple filters, but I wanted to be able to ignore certain filters if I needed to. So let's say, using this data frame as an example, if I wanted to add more filters to this, we already have one filter here, right? Let's say I wanted to add more filters. Let's say I also want rows where call O3 is equal to orange. So I would add the OR operator here and then create a new condition saying df01 call O3 is equal to orange. And when I run this, this is the result. All right, now back to the issue that I was having. Because we are specifying all of the conditions or all of the filters in the code, I wasn't sure how exactly I would go about ignoring a filter if I needed to. Fortunately, after some thinking, I came up with the solution to use a true mask. So basically these conditions, they evaluate to Boolean masks, and then those masks get used to index the data frame, right? If you want to ignore a certain mask, or if you want to make a certain mask, let's say a quote-unquote pass-through mask, you can set it as a true mask. A true mask is basically where the entire array is just true values. So let's try demonstrating this. So I'm going to set up a little example here. So let's say condition O1 is equal to 0, condition O2 is also equal to 0, then param O1, which is going to be our first parameter, is empty, param O2 is also empty, and then we have our true mask, which is going to be a list of true values. So true for x in range, df01 shape 0. This basically gives us the number of rows in df01, and then we are using that number in range. So this is going to create a list of true values that is as long as the number of rows in df01 data frame. All right, so now let's write some logic to determine whether to use a condition or a true mask. So we're going to say if param O1 is equal to nothing, then condition O1 is true mask. Else, so basically if some data has been passed into param O1, then we use a proper condition, which in this case is df call O1 is equal to param O1. And then we do the same thing for condition O2 and param O2. All right, so that is our logic. Now let's test it out. Let's see if this works. So I'm going to pass in both of these conditions. We're going to pass condition O1 and then use the bitwise AND operator and pass in condition O2. All right, so before we run this, I realized that I have a little mistake in my code where I forgot to make this true mask a series, because if this is not a series, if this is just a list, then this operation is invalid. So I'm going to get an error if I try to run this. All right, so now that I've made that change and we have passed in both of these conditions, keeping in mind that both param O1 and param O2 are empty, let's run this and see what the result is. All right, so as you can see, all of the rows get returned because we are basically using two true masks to index this data frame. All right, let's try passing in a value to one of the parameters. Let's try passing in A to param O1, but no data to param O2. As you can see, it works. All right, so now let's try not passing in any data to param O1 and pass orange to param O2. When I run this, you can see the result. So basically, in this case, condition O1 or filter O1 gets ignored and filter O2 gets used. So in my project, I had, I think, 5 fields, if I remember right. I had 5 different filters and I needed to be able to ignore some of those filters. So I had a start date, an end date, a voucher number, a customer name, and an item name. And I wanted to be able to ignore certain filters, like for example, the voucher number. So the user may not necessarily always type in a voucher number, right? Or there might be other situations where some of the other filters might not be required. However, I needed to make an expression where all of the filters were included, but some of them could become pass-through filters if need be. And this is my solution to that, basically using a true mask. And it's kind of interesting because I had to go back to doing bitwise operations in order to understand whether this would work properly or not. So just to do it on paper, quote unquote, let's take two 4-bit numbers. Let's say we have, I don't know, 1101 and 1010. So if we do an AND operation between both of these numbers, 1 and 1 is true, so 1. 1 and 0 is false, so 0. 0 and 1 is false, and 1 and 0 is also false. So this is the result of our AND operation, right? But watch what happens when I change either one of these numbers to a true mask. So basically where all the bits are just 1. Let's say I change this one to a true mask. Now let's try doing this calculation. So 1 and 1 is 1, 1 and 1 is 1, 0 and 1 is 0, and 1 and 1 is 1. As you can see, this top value basically just passed through this mask. And we could do a similar thing with the bottom number as well, where we use the top number as a true mask and the bottom number just passes through this mask. So 1 and 1 is 1, 1 and 0 is 0, 1 and 1 is 1, and 1 and 0 is 0. So as you can see, even in this operation, it basically passed through. This is pretty much how I figured out that, okay, this is how I could do it. I used a true mask, and fortunately, when it comes to AND operations, the order of the operations doesn't matter. So I didn't have to worry about what order I was putting the filters in. I could set whatever order I wanted. So yeah, this is how I solved a problem that I had in one of my data science projects, and I wanted to share it. If anybody who watches this video does data science related stuff, or even uses pandas for any other purpose, and you think there's a better way to do this, because I'm pretty sure there might be a better, more, let's say, elegant way to do it, or probably maybe a more performance friendly way to do it. I don't know. If you guys have suggestions for better ways to do it, feel free to let me know, because I'm always looking to learn. I'm still kind of a beginner with pandas. I've been using it for a couple of projects, but there's still so much of pandas for me to explore.